Right, let's go ahead and look at these fraction exponent examples from worksheet 1. Now I covered the second half here so that I have a little bit of scratch work. So we're going to work down instead of across. All right, so multiply. First thing I'm going to do is A 7/4 times 3/2. So that's 21 over 8. Okay, A to the 1/2. Now, in order to speed this up, okay, so we've got B to the 3/2 and B to the 1/2. Okay, so I need to add 21 over 8 plus 1/2 gives me 21 over 8 plus 4 over 8, 25 over 8. We need to subtract 3 over 2 minus 1 over 2 is 2 over 2 is 1. Okay, so we end up with A to the 25 over 8 and B to the first. Okay, 23. Denominator, we have power to a power, so we have to do 1/2 times 4/3, which is, let's reduce, 2/3. Okay, then we have negative 1/2 times 4/3. Let's reduce, so we get negative 2/3. So we have m squared n to the first, m to the 2/3, and n to the negative 2/3. Okay, so now we have another exponent rule. We have to combine our bases. Okay, so 2 minus 2/3. Okay, so that would be 6/3 minus 2/3 is 4/3. Okay, and we get 1 minus minus 2/3. Okay, 1, so that's 3/3 plus 2/3 is 5/3. So we end up with m to the 4/3 and n to the 5/3. Okay, so let's do number 25. Okay, scratch work. Okay, so I have my exponent rule, power to a power, negative 1/2 times 4/3, negative 2/3. Okay, I do see this negative exponent here, so I'm going to go ahead and move that. Okay, y to the 2/3 doesn't move. Okay, x to the negative 2/3 will move, and y to the 5/3 will not move. Okay, so let's go ahead and combine. I have y, y, y. Okay, negative 2/3. I could subtract and then subtract, so that is negative 9/3, which is negative 3. Okay, now that would be in the numerator, right? Negative 2/3 minus 2/3 minus 5/3. So I was going to the numerator, which is going to leave me with y to the negative 3. I don't want y to the negative 3. I want 1 over y cubed. So we've got a y cubed here. Now we have the x's. So that's 1 plus 2/3. Okay, 3/3 plus 2/3 is 5/3. Okay, x to the 5/3. Okay, let's go 22, 24, 26. Okay, so I see this exponent rule here, and I see a negative and a negative. Okay, y squared, 1/2 times 2, right, so just over 1, is 1. Okay, x to the 3/2. Now this y and this y are both going to move. Okay, now I'm going to combine. So I've got y, and then I've got x and x. Okay. So for the y's, we get 2 plus 2 minus 5/3. Okay, so 4. 4 is 12/3 minus 5/3, so that's 7/3. Y to the 7/3. Okay. Next, we've got the x's. So 1 plus 3/2, so that's 2/2 plus 3/2 is 5/2. X to the 5/2. Turns out I don't need the denominator, so we're just going to turn that into our box. Okay, let's do 24. Okay, so I see one negative exponent, but it's with an integer, so let's go ahead and rewrite that. Let's see if we can't combine any of our work. I see y and y. Okay, 4 plus 5/4. Okay, so 4 is going to be 16/4 plus 5/4. So this is going to be y to the 21/4. Okay, so let's leave this x squared where it is. This is going to be x to the negative 4. And so now let's combine that. This is going to be 2 minus 4, so 6. X to the 6th, y to the 21/4. Okay, 26. Got a fraction exponents. I don't see any negatives, so let's go ahead and combine. So I've got y, and I've got a y down here. All right, I think what I'm going to do, because I can look ahead, I notice that distributing my 1/2 is going to result in an integer exponent. So let's do that first. 3/2. I'm going to go ahead and add x to the first so I can see it. Y to the 1/4. This is going to give me x to the first and y to the first. So I notice that my x's are going to cancel out. 1 minus 1 is 0. X to the 0 is 1. Okay, so I've got y. 3/2 plus 1/4 minus 1. Okay, so let's do common denominator of 4. So times 2. 6/4 and 4/4. So 7 minus 4 is 3. Okay, 3/7. Y to the 3/7. Notice that there is no fraction exponents in our denominators. Let's go ahead and evaluate. I'm going to write in exponent form. 4 is 2 squared due to the factor tree. Then I'm going to use my exponent rules. 2 times 3/2 is 3. 2 cubed. Now I can leave it in exponent form, or I can actually do 2 cubed. So 2 times 2 times 2 is 8. Okay, 8 to the 2/3. I'm going to start with the factor tree. 8 is 2 times 2 times 2. Okay, so I'm going to replace 8 with 2 cubed. Do my exponent rules. 3 times 2/3 is 2. So we end up with 2 squared. Okay, 2 squared is the result. It can be written as 4. Notice here that the negative is included. Okay, so this is going to be -1, 2 times 2 times 2. -1, 2 cubed. All right, keep in mind from the video that -1 is the same as -1 cubed. So I'm going to pick the power that matches this denominator here. Okay, -1 cubed, 2 cubed. Then I'm going to distribute my exponent. Okay, so -1 squared, 3 times 2/3. So when -1 times -1 is positive, 4. The only difference between questions 3 and 4 is that in this one, the negative is assumed to be unattached to the number. Okay, so 8 is 2 cubed. So I'm going to replace 8 with 2 cubed. Okay, I'm just going to make that negative one time so it's clear. Okay, exponent rule, 3 times 2/3 reduces to 2. Okay, and negative 4. Let's do the next row. Okay, so I'm going to add some grouping symbols here. And I'm going to reciprocal. So the answer is 1/4. 9 to the negative 1/2. All right, so 2 ways to rewrite this. One way is to do this. The other equivalent way is to actually take 1 over that base. Sometimes the first way is more user-friendly, sometimes the second way. This particular case, I'm going to do this one. Okay, the factor tree for 9 is 3 times 3. And so this is 1 over 3 squared to the 1/2. Okay, exponent rule, 2 times 1/2 is 1. Okay, so that gives me 3 to the 1st. Okay, 125 to the negative 1/3. Okay, so I'm going to do this the second way like I did here. Okay, 1 over 125 positive 1/3. Factor tree. Okay, so I know that 5 squared is 25. 25 times 5 is 125. So this is 5 times 25. Okay, so 5 cubed. Okay. Exponent rule, 3 times 1/3 is 1. So we get 1 over 5 to the 1st. Okay. Next. 16 to the negative 3/2. Okay. So again, I'm going to rewrite this. 1 over positive 3/2. Okay. 16. Okay, so I'm going to start my factor tree. I know it's 4 times 4, but 4 is also 2 times 2. So I'm going to go down all the way to 2's because that's still a repeated factor. 2 to the 4th. Okay, my exponent rule says 4 times 3/2, so that's 12 is 6. So it gives me 1 over 2 to the 6th. I'm going to leave it in exponent form here. Now let's do the next row. Okay, negative exponent. 81 negative 3/4. Okay. All right, let's do a factor tree. Now I know 81 is 9 times 9, but that breaks down even further into 3's. And so we end up with 3 to the 4th. Okay, my exponent rule says that you multiply, so we get 3. 1 over 3 cubed. So I can leave it in exponent form, or equivalently, 1 over 27. Okay, notice the negative here and the negative here. Negative not included, so I'm going to rewrite it with the correct grouping symbols. Okay, negative 1 is going to stay. The 64, which is attached to the negative exponent, is going to move. Okay, 64 is 8 times 8? Yeah, okay. So this is 2 times 2 times 2, 2 times 2 times 2. Okay, so that's 2 to the 6th. Okay, exponent rule says 6 times 2/3, so this is 12 over 3 is 4. Okay, leaves me with negative 1, 2 to the 4th. Okay, so I can leave it like this, or 2 to the 4th is equivalent to negative 1 over 16. All right, negative in the grouping, negative exponent outside. So let's go ahead and rewrite this to start. All right, similar factor tree here. So I'm going to go ahead and start with, okay, negative 1. We'll start with the first power, and 2 to the 6th. Let's change this to brackets so we can tell where the grouping is, and leave my 2/3. Knowing that I'm about to distribute my exponent, I see negative 1 to the 1st. Keep in mind, these two things are equal, right? Negative 1 times negative 1 times negative 1 is actually still negative 1, okay? So I'm going to rewrite this. Okay, now I'm going to distribute. So we end up with negative 1 squared, 12 over 3 is 4. Okay? So negative 1 squared is positive 1, 2 to the 4th, or positive 1 over 16. Okay, last one. 1 over 25 and a negative 5 halves. So I'm going to change this to a positive 5 halves. And reciprocal, right? 25 over 1 is just 25. Okay, so my factor tree says that 25 is 5 squared. Exponent rule. Okay, 2 times 5 halves is 5. So we end up with 5 to the 5th, and I'm going to go ahead and leave it in exponent form.